When solving quadratics, it's important to be able to estimate right away how many solutions you're expecting to have. Your options are you could have no solution, you could have one solution, or you could have two solutions. Keep in mind those solutions are the x-intercepts on the graph. So when you're solving this, you're really answering how many x-intercepts does this graph have? None, one, or two. So when I look at these problems below, our goal is not to solve them, it's just to estimate how many x-intercepts would there be. So if I look at problem A, to get the x plus 4 by itself to undo the squared, I would do the square root of both sides. And just like when we did complete the square, anytime you square root the number 20, you don't just get the positive answer for the number 20, square root, you also have the negative version, because when that negative number got squared, it would have ended up positive anyway. So because of this positive and negative, when we square root, this is going to have two solutions. If we look at problem D, here if I square root both sides of the equation, the squared and square root cancel out, but the square root of 0, there's no such thing as positive 0 and negative 0. They're both 0. So no matter what, this is only going to have one solution. 5 minus 10x equals 0. And I would solve for x. One solution. Meaning only one x-intercept on the graph compared to two x-intercepts. Visually, a one x-intercept graph would be like this compared to two x-intercepts on the graph. We'll cross through twice. And situation B, here when we try to square root both sides, the square root of negative 2, we can't square root negative 2. There is nothing that squared makes negative 2, so this has no solution, meaning it just has no x-intercepts. On a graph, the graph would be somewhere up here like this. I didn't ever need to solve completely, I just was estimating how many solutions or how many x-intercepts does this particular equation have. So in general, you're going to end up with a no solution or no x-intercepts if you do the square root of a negative number. You're going to end up with only one solution if you end up square rooting 0, because there's no difference between positive 0 and negative 0. And you're going to end up with two solutions if you square root a positive number. And that's because we always have to think about a positive answer of that square root and the negative version of that square root. Similar to that plus and minus positive negative in the quadratic formula. Gives you two answers.